Okay, so we're going to talk about this. It's 2.3, number 1. And what they want you to do is they gave you information like y equals negative 1/4 x plus 3. They want you to tell me the domain and whether it's discrete or continuous, another representation, and then the growth factor. So which one of these do you already know about? Which one of these? Okay, thank you for letting me know, hon. Which one of these do you want to talk about first? Which one of these makes the most sense to go first? In the chat. Growth factor, perfect. Looking at your function, what is your growth factor? Yeah, it's that fraction. Very good. So here it says type of function and the difference or growth factor. So when they're asking what type of function is this, does anybody know if I graph this, what would the picture be? Yeah, it's a line. Very good. So I'm going to copy this down. Y equals negative 1/4 x plus 3. Were you guys right? Was that a line? Everyone's like, yeah, Miss Johnson. Okay, so this is a line. So I'm going to type here linear function. Okay. Now, what do they mean, Miss Johnson, between difference and growth factor? Well, difference means like when I make a table of these values, it's a constant difference versus it being a growth factor. Does that make sense? Okay. So what does this one have? Does this one have a growth factor or a difference? Yeah, it's arithmetic versus geometric. Very good. Very good. So this one is, no, sorry. So because it's a linear function, this tells me it has a constant difference. Remember? Let me show you. If I make a table, how do I do this? What's the best way to do this? Oh, I'll put my table right here. So when I make my table of values right here, right? If I plug in 0, what would my y be? When I plug in 0 here, what would my y be? Yeah, 3. Very good. When I plug in 1, what would my y be? Very good. When I plug in 1, what would my y be? Yeah, 2.75, right? If you don't know, you can plug it in here. Look, watch. Take this, copy, paste, and put this as a 1. See? 2.75, yeah. And if I put a 2 here, then I would plug a 2 here. Do you guys all think my table forming? Okay. So this is my little table. This is just another representation. I could also use this graph. It doesn't matter. But do you remember how before we used to do this thing? And we used to subtract here and we'd say, oh, this is down by 1/4. And see how this again would be down by 1/4 again. And do you see how this is all the same? And because this is all the same, that's a constant difference. So this is because this is all the same. Does that make sense? Exactly. So here I would type my constant difference or slope equals negative 1/4. Does that make sense? Okay. Okay, so we did a different representation. Actually, we did 2. Here we answered is what type of function it is. It's linear. Here we answered whether it's difference or growth. It's a difference. And then the last but not least, is this continuous or discrete? Who remembers what continuous and discrete are? What do I What do I write for continuous? What do I write for discrete? Very good. Why is it that? How can I tell the difference between continuous or discrete? Who remembers? If you don't remember, hint, hint, go to your notes. Oops, sorry. Okay, let me go to, I don't know where I am, guys. Hold on a sec. Oh, there's my notes. So here we had this whole thing. I'm going to zoom in. And it says, let's see, where did we put that? Where do we put it? Oh, is this in 2.2 and I'm in the wrong section? Y'all are nice to me. Hold on a second. Oh yeah, this is where it was. Make it smaller, Miss Johnson. So we said, yeah, that's domain. Aha, continuous because it's connected. Discrete because it's what? Yes, very good. Oh, someone put this already. Someone put, Miss Johnson, it's discrete because it's not connected. Continuous is connected. Let me grab this person's little thing right here. Someone else said something very similar. They said discrete means separate dots, Miss Johnson. I am going to show you. This is what someone said. Discrete isn't continuous. Discrete isn't connected. Continuous is connected. Got it? Okay, so going back over here. So looking at our picture, is this a picture of continuous or discrete? Person says discrete isn't connected. Is this connected? Is this connected? Yeah, so therefore, what would I write here? What do I need to write here? What do I write here? Yeah, it's continuous. And then to remind you, because points are connected. Hey, are you typing this on yours? Why not? Get it on there. Let's go. Okay, so because points are connected, done. Okay, the domain. We have to talk about the domain. What did we talk about the domain? What question did I ask you about domain? I think that was on this one, maybe. Nope, it was on this one. Making you all dizzy. Oh, what is domain? It is all possible values of x that make sense for the x. Okay, so remember, for this context of the books, we didn't include negatives, fractions, decimals, square roots. Okay, Ms. Johnson, but this one doesn't have a context. Okay, what numbers are we using then? Or a little better, what numbers are we not using? What numbers are we not using in this context here? Yeah, we're using all of them, right? Someone said, hey, Ms. Johnson, what about the numbers bigger than 0? No, look, what about these ones? These are less than 0, right? You see them? See how every number here is represented? So, Ms. Johnson, what do you want me to put for domain? So domain, all real numbers. Ms. Johnson, how did you know it was all real numbers? Look, are there any missing numbers here? Right? And some people would say, Miss Johnson, are fractions included? Yeah, you guys put fractions right here. These are fractions, right? 2.75 is a fraction. Questions? Okay, let me do one more because I think now we have it. Now we're like, oh, I get it. Okay, Miss Johnson. All right. So this one says, given the function f of 1 equals 1 and f of n equals 2/3 of f of n minus 1. Anybody recognize this guy? Anybody recognize this guy? Okay, is this a recursive function or an explicit function? Yes, it's recursive. So because it's recursive, then I'm going to start making a list of numbers. So I'm going to start making a list of numbers. Okay. So I'm going to make a sequence of numbers. It's also considered a table, but I'm just going to make it a little bit different just so it makes sense. So the first number that I should put is what? What's the very first number I should put? What's the very first number I should put? What's the first number in our sequence? Yeah, it's a 1. Ms. Jonathan, how did you know it was 1? Because it says it right here. Your first number is 1. Okay. How do you get to the second number? What would you do to get to the second number? What would you do to get to the second number? Very good. By the way, those of you who are not participating, get in there and get your answers in so you get all your mistakes out. Right? Yeah, someone said 2/3. What the heck? Why would someone put 2/3 there? And I realized that this should be a function. This should be this. Sorry. Let me go this way. 1, 2/3, comma. Sorry, I don't like this. This was yucky. Where did the 2/3 come from? Oh, Nayeli says, oh, the next number. This tells you how to get to the next number. Very good. How did she know that it was? Oh, because you multiply by the previous. Oh, okay, I get it. So to get to the next number, remember we talked about this? We multiply by 2/3. So this guy right here is just 2/3 times 1. Yes? Okay. What would I do to get my second number? Second number. Not plus right there, but times, and then you're good, I think. That's perfect. Yeah. Someone said, Miss Johnson, just multiply 2/3 times 2/3. Okay, wait. So up here, what I'm going to do is I'm going to put the math. So this would almost like be my table. I'm going to put my table down here. My table would look like this. 1, 1. Miss Johnson likes her tables, right, guys? Why isn't it letting me continue? Oh, man. Okay, fine. I'll put it right here. 1. And then this guy would be 1 times 2/3, right? And then the following line, if you guys know Miss Johnson, right? 1 times 2. Oops. This is not 1, Miss Johnson. Did everybody see my mistake? You guys all see my mistake? Shouldn't be 1. What should this be? Come on, y'all. What should that be?
2.
Yes. Yeah, hey, you guys, if I'm gonna make a mistake, tell me. Don't like let me live on forever and ever. Be like, Miss Johnson, like if I had a booger in my nose, Miss Johnson, you got a boogie in your nose. Like, tell me. Okay, so 1 times 2/3, yes? So this shouldn't be 1. What should this be? 3, right? So this would be 1 times 2/3 times 2/3, right? Okay, so continue on, Miss Johnson. So this right here would be what, like 4/6? That's my math. 4/6. 4/9. 4/9. I don't know how to do math. 4/9. And then you'd continue. Help me. Times 2/3. What would the next one be? Yeah. So what is that? 8/27. Right? Okay, and then I'm going to put comma, dot, dot, dot. Oops, not there. Sorry, not there. Here, comma, dot, dot, dot. That means and so on, right? Okay, there's I made a sequence. I also made a table. If you want to graph these out, you can graph them on a table. That makes it more fantastic. So 1 2/3. And then this was, no, that was wrong. This is 1. And then this one's 2/3. And this one's 4/9. This one's 8/27. This is 3. This is 2. This is 2. This is 3. This is 4. Okay, we good? So there's my function. All right, if we zoom in a little bit, it looks a little more functiony. Okay. Now what do I do? What do you want to talk about? This or this? This one. Growth factor or constant difference? Growth factor or constant difference? Yeah, it's a growth factor. Why is it growth factor? Someone explain. Oops, we should say of what? Of growth factor of what? Yes, because it's growing exponentially. Remember, these are times, 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 times. If you look at my previous slide, this was minus, minus, minus. This constant difference. And then remember our picture, it looked like a line. Okay, this one, the growth factor is 2/3. Very good. 2/3. Right? So what type of function is it? Is it still linear? This one we said was linear. Is this one going to be linear? Yeah, actually right there. Growing exponentially means that it's an exponential function. Very good. Very good. Okay, so exponential, Miss Johnson, because it's multiplying, yes. Growth factor because it's multiplying, yes. Okay, last little bit. Let's do discrete or continuous. Discrete or continuous? Look. What was the words that one of your, discrete isn't connected. Continuous is connected. So are these dots connected? Yes, very good. These aren't connected, right? Like you got to go back into like preschool or whatever. And remember you would play connect the dots, right? So no one connected these dots for you. So this is considered discrete. Discrete because the points are not connected, which makes sense, right? Because like when I was plugging in my table, I plugged in 1 and I plugged in 2. What number did I not plug in? I didn't plug in 1.5. Okay. Okay, last piece, domain. What is the domain? Very good. Domain is the natural numbers. Natural numbers. If you wrote like this fancy little thing and you went 1, 2, 3, 4, dot, 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 that's another way to do it. Natural numbers are just your counting numbers. So if you brought in like someone's little brother and they were in like, I don't know, 1st grade and you're like, count for us. The numbers that kid would say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, those are what natural numbers are. Okay. All right. So I need you to continue on to 8, 9, 10, and then we'll meet back and we'll check your answers. Okay. Very good.